So here we have a reaction between magnesium and hydrochloric acid to produce magnesium chloride and hydrogen gas. Now, up until this point in the semester, you probably would have read this as one atom of magnesium reacts with 2 molecules of hydrochloric acid to produce 1 molecule of magnesium chloride and 1 molecule of hydrogen gas. Remember that where we don't see a coefficient, a big number out front, it's understood that there is a 1 in front of all of those. But let's just put those in there to be really clear. But really, we can read this in another way. It's all about ratios of particles that are reacting. So we can also read this in terms of moles. This says that 1 mole of magnesium reacts with 2 moles of hydrochloric acid to produce 1 mole of magnesium chloride and 1 mole of hydrogen gas. Okay. So just by reading that equation out, okay, we can answer this question. How many moles of hydrogen are obtained from 2 moles of hydrochloric acid? Well, our reaction tells us that for every 2 moles of hydrochloric acid that reacts, that's going to produce 1 mole of hydrogen gas. Okay. We can also answer question 2 just by reading the equation. We know that 1 mole of magnesium reacts with 2 moles of hydrochloric acid. To answer questions 3 and 4, we have to think a little bit more generally. We have to generalize relationships. We have to establish relationships here. Okay. So question 3 asks how many moles of magnesium chloride would be produced from 4 moles of HCl. Well, if I look at my reaction, it tells me that for every 2 moles of hydrochloric acid that react, that's going to produce 1 mole of magnesium chloride. Well, I have 4. So let's actually write that relationship between my hydrochloric acid and my magnesium chloride as an equivalency. Okay. Let's do it over here. So for every 2 moles of HCl that react, that's going to produce 1 mole of magnesium chloride. Okay. Now we can use this as a conversion factor. We're going to ask the question, how many moles of magnesium chloride could I produce with 4 moles of HCl? Notice that I am explicitly including my label of HCl here, okay, because this isn't just 4 moles, this is 4 moles of HCl. Okay. Now I'm going to multiply that 4 moles of HCl by my conversion factor here in such a way that my moles of HCl cancel out. For every 2 moles of HCl that react, that's going to produce 1 mole of magnesium chloride. And we can see that if we multiply, if we look at our units, moles of HCl times moles of magnesium chloride divided by moles of HCl, my unit of moles HCl cancel out. It's not just moles, it's moles of HCl that cancel, leaving me with moles of magnesium chloride, which is what I wanted. Okay. 4 times 1 divided by 2, 2 moles of HCl. Oh, excuse me. 2 moles of magnesium chloride can be produced from 4 moles of HCl. We can answer question 4 just like that. But this time, we're looking for a relationship between magnesium and HCl rather than magnesium chloride and HCl. The process is the same. It doesn't matter that magnesium chloride is a product and that HCl is a reactant. And it doesn't matter if that magnesium is a reactant and so is HCl. You can still define your mole ratios between any part of your chemical equation. So now I'm interested in a relationship between moles of magnesium and moles of HCl. My equation tells me that for every 1 mole of magnesium that reacts, that's going to be reacting with 2 moles of HCl. Okay. So now I can use that like a conversion factor. I want to know how many moles of magnesium would react with 6 moles of HCl. Well, my mole ratio that I got from a balanced chemical equation tells me that for every 2 moles of HCl that reacts, that's going to react with 1 mole of magnesium. So again, we see that moles of HCl as a unit has canceled, leaving me with moles of magnesium, which is what I wanted. 6 times 1 divided by 2 is 3 moles of magnesium. So that's how you can use mole ratios to convert between moles of one substance and another in a chemical equation.